Hi there. In this lecture, we are going to review EIGRP load balancing. Therefore, after this lecture, I expect you to be able to describe and configure EIGRP load balancing. Let's start our today's mission. In today's world, most of businesses are IT-based, and downtime in IT is not acceptable even for 1 second. Therefore, network administrators provide redundancy for their networks. They put 2 routers, for example, 2 connections, 2 internet connections, and any redundancy that are affordable for them based on their budgets. As we saw before, EIGRP convergence time, thanks to the dual algorithm, is very fast. And in the situations that we have redundancy in our connections or routes, when successor route fails, the feasible successor route instantly substitute with successor route. However, someone may ask that we have 2 connections. One of them is active and one of them is passive until the active fails. But couldn't we use both of these links in the normal state? The answer is yes. This is called load balancing or load sharing. With load balancing or load sharing, we could have 2 or more connections and share our traffic on both or triples or any other connections that we have. EIGRP lets us to share our network traffic up to 16 or more paths. This variable is called maximum path. The number of maximum paths is depend on your iOS and your platform. Formerly, EIGRP provides 6, and now it could provide 16 or more maximum paths. By default, only 4 paths are inserted in the routing table, and if you have more than 4 routes in your topology, you have to change this default value. We will do it in the next slide. Another question arises. EIGRP's load balancing is equal cost or unequal cost. You may know that some routing protocols like OSPF has the load balancing feature, but in them load balancing only occurs when you have redundant paths with the same cost or manipulate the cost, which is very risky. But EIGRP's load balancing is unequal. I mean, if your redundant paths do not have the same cost, EIGRP could balance your traffic on both of these links. But another concerns may arise. How EIGRP balance our traffic on these links? They may be very different links. For example, this could be a T1 line with 1 and 544 megabits per second, and this one may be a fast Ethernet with 100 megabits per second. Does EIGRP load balance traffic 50-50 on these links or not? Don't worry about EIGRP. EIGRP is the best. In these situations that you have unequal cost redundant path, EIGRP balances the traffic based on the metrics, and better metrics should take more traffics, and the traffic is not balanced 50-50 or any equal sharing. With variance, you define the variance between the best metric and the other metrics that are acceptable for load sharing or being in the routing table. I mean, for example, is the feasible distance for network X here is 100, just for simplicity. The variance by default is 1, and the acceptable range of metrics that could be considered for routing table are between 100 and 100, and this is equal cost load balancing, not unequal cost load balancing. Therefore, EIGRP is not unequal cost load balancing by default because of the multiplier is 1. And after we change this multiplier, for example, we change it to 12, and now the result would be 1200. And the acceptable range of metrics for being in the routing table is between 100 and 1200. And if your metrics are in this range, they could be in the routing table, otherwise they couldn't. Now it's the time of configuration. I make a map like this. As you see, I have 5 routers to reach network 192.168.11.0/24 from router 1. I change the bandwidth of these interfaces to manipulate EIGRP calculation. Now you will see that only one of these routes are active and the others are visible successor routes, and wait until the successor route fails to become active. Now we want to learn that in these situations what could we do to use EIGRP load balancing feature. So let's do it. From the perspective of router 1, let's see the routing table. Show IP route. I just want to see the route for network 192.168.11.0. So I say include 192.168.11.0. And as you see that there is only one route through fast Ethernet 0/0, which is this link. Now, how could we understand that the others are in topology table? Yes, you know that. Show IP EIGRP topology. Again, include or section 192.168.11.0. You see that there are 5 routes in the topology table, but only one of them are active. Which one? The one with the lowest metric from fast Ethernet 0/0. We want to change this behavior and force router 1 to consider other routes. To do this, we go to the router mode, configure terminal, router EIGRP1. I select the S number 1, and here we say that variance, and you see that there is the difference between 33,280 and 58,880. And if I change the variance to 30 for sure. Now EIGRP should consider the other routes and put them in the routing table. If you have some routes and you see that there is no in the topology table, they may not be the successor nor feasible successor. They do not pass the feasibility conditions, and so they do not enter in the topology table. How could you see those kinds of routes? You could see them with show IP EIGRP topology all links. With the all links keyword, you could see the routes which are not successor nor feasible successor. And you see that for 11.0 we do not have one of these. All 5 routes are there in the topology table. You could see the value of variance and the maximum path by the command show IP protocols. As you see, the maximum metric variance is 30 as we set it, and the maximum path by default is 4. Therefore now when we see the routing table with show IP route include 192.168.11.0, let me change include with section. You see that 4 routes are in the routing table and the traffic could be balanced based on their metrics, but there is no the 5th path, even it is in the variance range. Now we want to put the 5th one too. So we go to the router mode with router EIGRP1 and say that the maximum path is, for example, 6. And now I expect to see the 5th route in the routing table too. And you see that the 5th router enters, and we have 5 routes in our routing table for the network 192.168.11.0. The variance and the maximum path are also applicable for IPv6. You go to the router EIGRP submode for IPv6 and enter these commands for IPv6 too. There is no any difference for this configuration between IPv4 and IPv6. Now it's summary time. In this lecture, we see the EIGRP load balancing process. You see that EIGRP could balance your traffic up to 16s or more based on your iOS and platform. EIGRP is unequal cost load balancing, but you have to configure it with the variance command, and we'll learn how to configure the variance and the maximum path in our routers. I hope this lecture helps you to improve your knowledge, and see you in the next lecture.